Now let's look at our very first proportions problem. And this is a very simple one. A business believes that 75% of its customers live in the county in which the business is located. A random sample of 150 customers yields 100 customers living in the same county. Using an alpha of 5%, right, does the sample data support the belief? Again, we're going to do this problem without the interpretations that we will do later, next class for instance. Let's first get the sample information down, or the information from the problem. Alright, the 75% is a belief. We're going to use that in the hypotheses. A random sample of 150 customers, that's the sample size n. The 100 is the x in the p-hat calculation, right? So the p-hat is going to be 100 divided by 150. Alright, so p-hat is always one whole number and an integer divided by another whole number, or another integer. Let's get a clean page here. So, our sample data. N, number of items in the sample, 150. Sample proportion, p-hat, if you like. You don't need to use the formula. Any of you can do that straight, of course. X, 100 people living in the same county, divided by 150 people total in the group, so 100 divided by 150 looks like 2/3, right? So 6,667. Remember, we're going to 4 significant places. Forget the preceding 0 in decimal place. Here's 1, 2, 3, 4, and the 4th number is rounded up, since the 5th number will also be a 6. Alright, second step is hypotheses. Null hypothesis will be that the true proportion is equal to the, in this case again, a believed value. Doesn't always have to be a belief. So just like the last problem, p is a true value, and that equals 0.75, which is the belief. The alternate is the complement, everything but that. P not equal to 0.75, and again that means that the true proportion is not equal to the believed proportion. Next step is to do calculations. We'll draw a diagram. So this is the hypothesized value of the true probability distribution of all possible sample proportions. If the null hypothesis is correct, then p is equal to 0.75. Just like the previous problem, we have an alpha of 5%. Alpha is the total area in the tails. We have 2 tails again, so we have 2.5% in each tail. So again, we're going to calculate these limits, critical limits. We'll abbreviate by CL, and for proportions that'll be P plus and minus the Z with half of alpha in each tail times standard deviation of that distribution, sigma sub p hat. So just like the previous problem, the Z with half of alpha in each tail is a Z with 2.5% in each tail, or the upper tail, and again that value hasn't changed, that's 1.96. Next thing we need is the standard deviation, sigma sub p hat, square root of p times q, or 1 minus p if you like, divided by n. Alright, p is 0.75, q is the complement, 1 minus p, 1 minus 0.75 or 0.25, divided by the sample size of 150. So let's pull out the calculator. 0.75 times 0.25 divided by 150. Take the square root, and the number in the screen of my calculator goes something like this: 0.03355 after that, and round it off to 4 places. Instead of 355, it would be 36. Okay, so there's my standard deviation to 4 significant places. Okay, so going over here, the 3 is the first one, 5 is the second, 3 again is the third, and 4 is the sixth is the fourth place. So now we're ready to calculate our critical limits. Alright, the p, the middle of the distribution, 0.75, plus and minus z value 1.96 times the standard deviation 0.3536. So the standard deviation still in the calculator, times 1.96. So 0.75 plus and minus 0.06930. So now we're going to go 0.75 minus 0.06930. So the lower limit of the acceptance region in this example will be 0.6807, 2, and then 0.75 plus that number 0.6930, and we get 0.8193. So let's redraw the distribution so we can see it on the same place here. The middle of the distribution is the p of 0.75. The lower limit is 0.6807. The upper limit 0.8193. Alright, so those are the two limits of the acceptance region. Right, that'll now define our decision rule. Alright, so that's the next step. Third step, decision rule. First part corresponds to the null hypothesis. If we get a sample proportion p hat which is between those two numbers, 0.6807 and 0.8193, just like the first problem. Again, we'll clean that up later. We'll say that we'll accept null hypothesis as being likely. Alright, so if it's in here, it's close to the believed value. So we'll say that belief looks good. Alternatively, if the sample value is far away from the bleed value, out here in the tails, then we won't accept the null. Alright, so if p hat is not between those two numbers, 0.6807 and 0.8193, we will reject the null. And in its place we'll accept the alternate. Okay, simple enough. Now we need to find our sample average. Sample average 2/3, 0.6667. And 0.6667 is somewhere below 0.68, so let's say it's down here somewhere. And that's our p hat for this particular example. Alright, so the decision in this case would be to follow the second part of the decision rule. So decision, since p hat is equal to 0.6667 is not between those limits of the acceptance region, 0.6807 and 0.8193, we will reject the null where its sample value is too far away from the hypothesized value, and in its place we will accept the alternate. And that's it, except for interpretations of these decisions and a cleaning up of the business of accepting the null hypothesis.